Let's now handle the ground orientation problem. There's basically many ways we can go about it. We could have used the contact point of the kart controller sphere. I think the easiest way to handle it is probably to create a ray object, and this is what we are going to do. I am going to select my viewport, click Shift and 1, push Tab to enter a wireframe, and I am going to go select my kart controller. From the outliner, kart controller, I'm going to go under physics and I'm going to reset that transformation. It's going to bring me back to my start position. And I'm going to click dot to focus it. And now I still have some rotation that is coming from my kart controller. I'm going to simply rebuild it, ensure that I'm looking straight. I'm going to rotate a little because I'm going to have to select my kart here and not the kart controller. So I'm going to select my kart and I'm going to push M to put the 3D cursor at the kart location. And I'm going to go under Objects and then Add to Render Layer, Ray and World. I am going to now select that world ray, offset it a bit, and holding select, I'm going to select my kart and I'm going to go under Objects and Attach to Active. So I'm creating a parent relationship. So my ray will always follow the kart. With my ray selected now, I'm going to go under Object Properties and I'm going to call it kart underscore ground. And I'm going to go down and transform, set the orientation to be in local space and reset that back all to 0. So it's at the exact same location as my kart. And I'm going to reset also the rotation. So now wherever my kart is going, my ray is aiming straight down. Now I'm going to access the ray properties. I am going to slightly increase the length of that ray. Let's put it at 1.5 for now. And update rate, I'm going to set it to 0 because I want to have a new update every frame. And I am going to enable the ray to be on my first collision layer and to intersect with also my first collision layer. And as I do that, I should get straight away a feedback. I got that little orange dot here that is telling me that I got a hit. Next, I'm going to need to change my actual kart controller. So back in my code, I am going to create a new variable for my kart ground that I'm going to append here. And I'm going to also create a bunch of new variables for interpolating my current ground normal with my ground orientation. So I'm going to have ground distance that is telling me 0, no hit, greater than 0, there's a hit. I am going to have my ground orientation looking straight up that we're going to interpolate, and my current ground normal by default also straight up. I'm going to scroll down and go under function update. And I am going to create a new function that I'm going to call ground info. And what ground info will do is going to take our current ray and is going to assign to ground distance 0 or the amount of hit if we have a hit or not. If we have a hit count greater than 0, we are going to check if the object hit by the ray is actually different than our control. This type of ray is asynchronous, so it means that it is an action that is added to the world physics update. It will not stall your pipeline. It would just be updated the next time the physics update. It will not request right now a result and stall everything. So when, in example, the kart jump over the ground and as it goes down, we might have a slight delay because of the gravity. So the ray might enter our kart controller and we don't want that. So if we are having that kind of hit, we are simply going to ignore it. Then we're going to store our hit normal. And we are going to invert the X, I believe it is necessary in this case, and the ground Z also. As I mentioned, as the kart controller, the sphere is pulled by the gravity. As it hit the ground, it might penetrate the ground a bit, which would cause our normal Z to be inverted. So by ensuring an absolute normal Z value, we are ensuring that it is always straight up. Now in my on update, give a little bit of space here. I am going to call my ground info to be updated every frame. And I'm going to add my interpolation of my ground orientation with the actual ground normal that we have been picking up here in our ground info function. And the last thing we have to do, since we have now our ground orientation interpolated, we are going to calculate a 3x3 rotation matrix from that ground orientation. And for that, we are going to use the math3 from normal function, helper function here, that is taking in parameter our ground orientation. As I push build again, our cart is slightly inverted. We are going to fix that. I'm going to hit space bar with the view 3D selected to enter render layer view. And I'm going to go under geometry and select my geometry camera. And under constraint, I'm going to go search my elliptic, and I'm simply going to invert the distance, the orbit value. So I was at 23 minus 25, let's say, and 12 is a bit too far. I'm going to invert, and I'm going to set minus 8 instead. Bring us straight back to our cart, just behind the cart. And for the lerp location, I feel last time that was a bit slow. So I'm going to crank it up at 10 for now. And since I'm looking the other way, I am going to now set that my current rotation start at 180. And as I build, I am looking straight at my track again. Let's go back hitting that ramp. As I go for a second run, I feel that the handling is a bit too sensitive. I'm going to change that. I'm going to halve that and put 0.05. I notice also that on the side here, we're having shadows that should not be there. And it's probably because our collision map is draw on our right depth render layer. So I'm going to select collision map, and I'm going to select object properties, and I'm simply going to disable it so it will not be rendered on the right depth, and like that is fixing our shadow. Another thing that I notice is it's a bit bumpy. So what we're going to do, we're going to select our cart controller here, cart controller, and under physics properties, we are going to low down the friction a bit, put it at 6.5 to have it more smooth. And total mass, let's set it to 100. And we are going to give a custom gravity vector to ensure that our cart will stick more on the ground that it is doing right now. It's still a bit bumpy. It's a bit of tweaking, just like any type of game. You always need to tweak a bit to end up with the good values. But we got everything in hand to have like some very realistic looking, well, realistic. It's relative. Good looking, feels right physics that can be applied to our cart. So we're going to hit our ramp here, and we're going to verify that our code to orient the cart is working, and it is working great. We are following the ground on the way up. Let's see on the way down. And yes, we're having now the cart orientation that have been properly handled. The next session will be to implement sound, and with that, we're going to wrap up our basic cart game.